For those of you who haven't done this task before, what do you see? Shout it out. Bananas. What else? Stickers. Boom. What else? Do we have shelves? Do we have shelves? Bananas on shelves. What else? Bye. Yellow. Boom. Okay. So once we start getting to the end here, that's when we start thinking of these other kinds of characteristics, right? When we're first asked to talk about these things, we're much more likely to call out the fact that they're on shelves before we mention the fact that they're yellow. When we see something like this, we might say green bananas or unripe bananas. When we see something like this, we might say ripe bananas or bananas with spots. If you're me, you might say bananas that are good for banana bread. But when we see something like this, we don't tend to say yellow. And that's because yellow is prototypical for bananas. So prototype theory is a theory of categorization in the mind, which basically says that we have either a distribution over potential attributes or a single prototype that things span outwards from of different kinds of concepts. And this influences what we tend to talk about. So a study was done almost 10 years ago now, taking a look at the frequency of different kinds of words in text corpora. And it was found in that study that something like murdering was almost 10 times more likely than something like blinking. Hopefully, in general, we tend to blink more than murder. Maybe murder can be 0, blinking can be much higher. But the fact is that we tend not to mention those things that kind of go without saying, those things that we expect, those things that correspond to our basic concepts of the world and what they tend to be like. And this is called human reporting bias, which is that the frequency with which people write about actions, outcomes, or properties isn't a reflection of their real world frequencies, right? They're a reflection of what our cognition is doing and then what we're saying as a function of that. This affects everything that a machine learning system can learn when it's training on data produced by people. So in a typical machine learning paradigm, first training data are generally collected and annotated. The model is then trained. From there, media can be ranked, filtered, or aggregated, and hopefully the output is evaluated before people then see the output. But before we even begin this process, the data itself that's collected encodes a subset of human perspectives, what people choose to talk about and how they choose to talk about them based on their experiences. So as a side note, I'll mention that sometimes in the ethical AI discussions, there's a question about whether you can ever have an unbiased data set. No, a data set by definition is biased because it is a subset of the world, right? It isn't everything in the world for all time. It is a selection, a biased selection of everything that there is. When we're talking about what people, I should say, as a computer scientist, sometimes we say humans instead of people. Gotta remember people. What people tend to say. Is stuff that has a lot of stereotyping, things like racism, things like sexism, as a function of the kinds of mental models we build up about the world. And that's reflected in the data. There's then further kinds of biases that are injected in the way we collect data, where we tend to collect data from, the kinds of annotations that we have on data, and et cetera from there. This has ripple effects throughout the system. So those biases at the start are now part and parcel of the machine learning system thenceforth. From there, the model is trained. And this is where we start seeing effects of the model choices. So for those of you who are more familiar with machine learning, we have things like underfitting and overfitting, which happens based on how much of different concepts you have represented in the data, too much or too little, roughly. We have things like default effect, where people tend to use loss function, objective functions that are what tend to be used in the field or for that model, whether or not that exactly fits the task. And anchoring bias, where those things don't tend to be questioned. This is just the way it's done. And those decisions further propagate through the machine learning system into what people eventually see. From there, the media are filtered, ranked, generated, and that's where we tend to see things like confirmation bias, where when we're looking at the output, we say, oh, this is good, this is working, because that's what we want to be true. And then from there, people see the output where they're heavily affected by automation bias. And in automation bias, you tend to agree with what an automatic system tells you. There's this sense that it's right, it's objective, despite all the stuff we know about the biases. There's just this sense that because it's coming from a machine, we should trust it. And this has horrible ramifications in the use of AI at large. But that's not the end of the story. From there, there's a further feedback loop. People see the output, they act on it, and then what they're acting on becomes part of the data that is then used for further machine learning training. So you can think of a social media feed, what you're reading, what you're clicking on, that then becomes what the model is further trained on. And so the initial recommendations that were biased are just further being encoded. And I like to call this bias laundering, in part because I made this GIF and I'm very proud of it. It's probably my greatest artistic achievement. But although it can be hard to pinpoint the exact biases and the exact sources of bias, we know that there's this whole underlying system of human biases throughout the entire process affecting what we eventually see and act on. So this brings us to the role of ethics in AI. So briefly, ethics doesn't provide the answer. There's often a misunderstanding about who gets to decide what is ethical, or that you can't really do ethics because there isn't one clear definition. That misunderstands what ethics does. Ethics gives you a way to analyze problems in light of different human values, decide among them, prioritize among them. It can be used to articulate and justify decisions. It's more a framework and mechanism for working through different problems, pulling out the different kinds of things at play and different sorts of values that you might want to hit on, rather than something that gives you the answer. And some example values are on the right here. These are the kinds of things that tend to be thought of and discussed in ethical AI work. Things like honor, kindness, equity, inclusion. Those are just some, and obviously each person will have sort of their own set of values that they prioritize. In the context of a company, this becomes the company's values that you all act on. And I have a whole other slide deck on that, so I'll try to shut up, but I'll just say quickly here that normative ethics is a particular flavor of ethics that's very useful to know about, because this gets at what you can do to be good. So this is things like virtue ethics, where you just try and do the thing that is good. Consequentialism, which is sort of like the end justifies the means. Deontological, where you have the set of rules, such as those given by your company, and you follow them. Your actions are based on your duty and obligation. So now I'll turn to how this all fits into the machine learning pipeline that previously I walked through about different kinds of human biases. So we can break this whole pipeline down and look at it through the different kinds of values that are in play at each step in the process. So when we're dealing with training data that gets collected and annotated, some of the values at play include the copyright of data instances, the consent of data providers, right? Usually when we write things online, we aren't thinking that this information is going to be swept up in a system that a large company will then profit from. We're not giving consent in an informed way, right? So this is another kind of value at play in the data used in machine learning systems. Things like fair pay for annotators. So it's quite common in the US to have annotations from places that are sort of lower, more poverty sort of areas. Actually, India is quite common, but here there's a company called Sama AI, I think, that there was recently a piece in Time about how Facebook uses Sama AI and generally does not provide a good environment for the workers. This is a kind of value you might want to think about. And then we also care about things like diversity in the data. Going on from there, we have the model training. I talked about things like the biases with underfitting and overfitting. The sort of corresponding value here is around the appropriateness of the loss function of the model. In the sort of third step here, where media are filtered or ranked, this is where we care about fairness. So algorithmic fairness deals with this issue of the pipeline, in the pipeline. This is where we tend to think about stereotype removal, although there's a lot to say about introducing stereotypes in the start, and maybe we don't need to do that. But generally, this is where that value tends to come in. Inclusion of users so that different kinds of people can interact with the output. And then once the output is there, there's usually values around trying to minimize social harm, even though all of these other things were not necessarily addressed beforehand. But this is sort of the general play of values within the machine learning pipeline. I have talks on each section of this pipeline. I'm going to try to go through very quickly just a few examples. So this first bit, training data collected and annotated, I wanted to focus on in particular because there's work here on data. I saw this in some of the posters. This came up in some of the talks before. This seems to be something that the audience here cares about. The values at play with data are particularly important because that point of data to model is the touch point of information flow between human knowledge and artificial intelligence, right? That's the moment that they connect. So it's critical to understand what's going on. So some ethical tensions relevant to data are things like benchmarking and reproducibility. In machine learning, we tend to release data sets so that others can benchmark against it, so that we can show that our results are reproducible. And that's good, right? Yay for this. But this comes up against some other ethical values, things like consent, not having the informed consent of the people represented in the data, amplification of people who would rather have their information private. So there's often a misunderstanding that if it exists on the web, well, then it's there public anyway. What's the harm in using it? But there's a difference between a single instance and the amplification and proliferation of that instance, right? So one of the points here is that even when you're trying to hit on some good ethical values, there are essentially always some other values that are in tension with it. There's no such thing as having like all the values. You have to prioritize among them. We might be interested in something like diversity in our data. That's often a stated goal in data collection currently. But this comes against things like exploitation and stereotyping. So to give an example of this, Google was trying to get more Black faces for the Pixel Unlock feature. And in order to collect data for this, they went to a homeless shelter in Atlanta and paid people $5 for their faces without explaining what it was for. Something they're going to make tons of profit off of, right? So this is exploitation. It's also a kind of stereotyping to think, oh, we need Black faces. Where are Black faces? Oh, a homeless shelter, right? But this was for the goal of diversity. So these things really come into tension if you don't have a sense of the larger landscape of values. Okay, I think because of time, I wasn't quite sure when I started, but I'm probably not going to walk through each of these in much more detail. For the media being filtered and ranked, the fairness of outcomes really comes into play. So I will talk about that for a second. This is where it's critical to evaluate for fairness and for inclusion. There's two steps here. One is to choose your metrics for evaluation based on the different kinds of errors your system is likely to make. And two is to disaggregate. That means looking at how well the system works across different contexts and populations. And to get everyone on the same page about this, some error trade-offs can be seen in the context of classification systems. So a classification system that decides whether something should be blurred for privacy in images, that's a situation where false positives are better than false negatives. So a false positive is something that doesn't need to be blurred, getting blurred, kind of a bummer. A false negative is something that needs to be blurred, but isn't blurred, which can lead to identity theft, right? So your evaluation and your loss function should take these things into account, which isn't so hard to do if you're thinking about how these things can be used and go wrong. Example of the reverse, false negatives are better than false positives, is in something like spam filtering. So a false negative would be email that spam isn't caught. So you see it in your inbox. That's usually just a little bit annoying. But a false positive is email flagged as spam, is removed from your inbox, which can be a loss if it's a friend or loved one or a job opportunity, which has happened to me in the past. So false positives are definitely something to prioritize in the kinds of evaluations you do and the kinds of models you build. But note too, that how the system is used is so critical to think through, because if it's the case that we can foresee people who are easily scammed using the system, then we're in a situation where an email that should be spam is not caught, and that can lead to a loss of wealth. So again, there are these trade-offs that you only really get at by thinking through the people and the context of use. The other aspect of evaluating for fairness and inclusion that still isn't a norm in machine learning, which just blows my mind because it's so obvious and so easy, but it's disaggregate, where you compare for each kind of subgroup and prediction, and then you compare how well the system does across the different subgroups. This is also called stratification, I think, in biological research. So for an example, looking at how well face detection works for women versus men. A critical part of this is understanding the different errors at play, as I mentioned before. So looking at those false positives and false negatives, this basic breakdown of these kinds of errors, true positives, false negatives, false positives, true negatives, they actually give you a lot of the metrics, or I guess all of the metrics used in classification systems. So just understanding this basic breakdown starts to tell you a lot about the actual metrics you should use for evaluation. And it turns out that these correspond to the same kind of fairness criteria that's talked about in work on algorithmic bias. So there's this notion of equality of opportunity across subgroups that is mathematically identical in classification systems to equal recall across subgroups. So this is fairly straightforward to do. For some reason, it's not part of the ML community thinking, and I really think it ought to be. It's fairly low-hanging fruit there. Another important thing about this is that disaggregated evaluation by specific subgroups isn't necessarily enough, because people are a collection of different characteristics that will have different kind of experiences as a function of those intersectional characteristics. So this comes from critical race theory. Kimberly Crenshaw pioneered this idea of intersectionality, where the experiences of a Black woman can't be guessed by the experience of a Black man and a white woman, right? There's something unique about being a Black woman that you can't get just by combining the other sorts of subgroups. So part of the evaluation really needs to take this social context into account. And how we get there is by foresight and development. I made this helpful, hopefully, chart in order to explain how to do foresight, break it up into the contexts, the people, and then look at the cross of those. So the use contexts are either intended, unintended, or out of scope. The people are users and those affected. And then you can quite simply break this down. So just to work through a text to image example, so this is where you type in text and it creates an image. You have intended users being artists, intended use cases being something like creative art, right? But you also have unintended users, something like a malicious ex-partner, and an unintended use case, which could be revenge porn, right? And this is one of the most serious issues, I should mention, with text to image is revenge porn. It's under discussed, probably because it disproportionately affects women. But by not doing these basic things, we're not addressing the full scope of issues that machine learning systems are really doing. All right, just to sort of end here, one of the ways to incentivize this kind of foresight, this kind of working through biases, and the different values at play is documentation practices. And one of the documentation practices that I developed with some colleagues at Google is this framework called model cards, where you essentially take all the stuff I just talked about and put it in a card. There's a lot to say about that. A lot of different companies are doing it in different kinds of ways. It's really kind of cool to see how people are talking about the systems that they're making. It helps with transparency, reproducibility, communication. I won't go into too much detail about it in the interest of time, but it essentially has basic information, details about training, use and findings, including this evaluation, which should be also in light of the fairness concerns. Okay, so biases affect what we say and do. Values can be used to navigate that complex space and when to prioritize what. And public-facing documentation can incentivize the thinking through the biases and values, as well as acting as an incentive for good behavior. By using foresight, this is quite straightforward to do. I gave a little chart to even help with foresight. And by doing this, we can move from machine learning that reflects the majority characteristics of the developers to something more like diverse and inclusive representation for more ethical AI. Thanks.